Hey all, continuing our discussion here of energy sources. So when we start thinking about kind of what we think of as alternative energy sources, remember that of the fossil fuels, really natural gas and coal are the ones that we use to create electricity. And we do use oil to create electricity, but really it's not kind of the majority use. Although, as I mentioned in a couple of places, I kind of touched on, Hawaii and Africa. So this, what we call biofuels or modern biofuels, they really actually offset kind of transportation or uses of oil rather than producing energy. So historically, biofuel is actually used for energy, and the easiest thing to imagine with biofuel is taking biology and using it to fuel. So again, kind of traditional biofuel is actually just kind of using a wood stove, right? And in that case, you are using it for energy. So you're taking cellulose or trees or cordwood, right? Chop up your wood, go out and cut down a few trees. Hopefully they're already dead. And you take those, you put them in a wood stove, you initiate a combustion reaction, and then there's heat produced. So that's actually a fuel that we've used for a really long time. And even if we're thinking about trees, you've then taken fast cycle carbon, so land biosphere, fast cycle carbon, the stuff that's stored in trees. It might be sequestered for 100 or 200 years in that tree, and you're then kind of adding it back, right? So it's not necessarily the same thing as taking kind of slow, rock cycle carbon and adding that. But we're not talking about burning wood here for energy. What we're talking about is modern biofuels, and they really fall into three categories. So ethanol, hopefully you're familiar with ethanol. It's actually the active ingredient we use as a psychoactive drug in alcohol. Essentially what we can do with ethanol is we can take plant matter, be it grains or corn or something with a high starch content. We use the process of enzymes to break those down into sugars. Then yeast will ferment those sugars and create ethanol. We then take that product and we distill it, we pull out the alcohol, and we can use it for a lot of different things, right? It burns, it's a source of energy. We add it to gasoline to kind of help the gasoline burn better. It also offsets some of the volume of hydrocarbon that you use in your gasoline. So generally, if you're buying gasoline for your car, it's 10 or 15% ethanol. But if you're buying it for your chainsaw or for your dirt bike, right, you want ethanol free because it burns a little bit differently in small engines. It's not quite a great additive. But either way, when we think of using ethanol or alcohol to produce energy, it is carbon neutral in a sense, right? So the combustion of ethanol, it's a hydrocarbon, right? That combustion reaction creates CO2. So we haven't solved that side of the problem. But the back side of the problem is solved in the sense that you're taking plants that have recently pulled carbon out of the atmosphere by photosynthesis. You're taking corn or grain, like I said, and that carbon that's pulled out, you're now adding back in. So you're kind of taking fast carbon and making fast carbon again. So hopefully, with that kind of understanding, you can see where these biofuels have their usage. So biodiesel is another example of a modern biofuel. And it has more uses than ethanol, right? So we take some fatty materials, stuff that has a high percentage of carbon and hydrogen, so vegetable oils, animal fats, grease from your favorite restaurant, and we take that material, we clean it, we refine it in a sense, we get it all clean, we add alcohol, and that causes a chemical reaction within the oil, and it creates some byproducts, but also this material that we call biodiesel, which is very similar in chemical structure to a diesel fuel. We don't quite get the full suite of different hydrocarbons like we get from refining crude oil, but biodiesel can be used in an engine that's designed to run on diesel fuel. And again, what we're seeing here is you're using something that very recently pulled carbon out of the atmosphere, and then you're adding carbon back in to the atmosphere. So the benefits of biofuel is really kind of the time, right? So again, reflecting back to our discussion, the details of the carbon cycle, the major kind of perturbation or the major change within the carbon cycle is when we as humans take deep carbon or slow carbon and add it to the carbon cycle. In these cases, ethanol and biodiesel, and then we'll go through one more, we're essentially taking fast carbon and putting that back into the atmosphere. So we're offsetting the amount of slow carbon that we were adding. So hopefully, again, you can understand that. This one's my favorite, renewable hydrocarbon, or what we would call a drop-in fuel. And this is different than ethanol and biodiesel. Specifically, it's different in the way that it can be applied, and it's actually much more useful than all of the others. It's actually much more useful and has a wider application. So essentially, what we could be thinking about here is algae, right? This is, in a sense, and this is kind of one way to do this, we're basically doing geology's work for it. So in the case of oil, again, this is geology stuff, we have organic material that lives in the ocean, little planktons, algae, all sorts of things that are made of fats. Those die, they get kind of trapped in geologic layers, and then they get buried, and they undergo, that burial causes them to break down into kerogens, and then ultimately these things that we call alkanes. Those are organic hydrocarbons. That essentially is crude oil. We take that sludge and we distill it, we separate it into different groups, and those all have different uses, right? So just kind of starting from the bottom to the top, I don't have them all memorized, but there's methane is the first one, CH4, butane, propane, 8 carbons is octane, decane is 10 carbons. All of those are different hydrocarbons that we use for traditional transportation, right? Like in your 1986 Honda Civic, if any of those are still on the road. My friend had one in high school. So the way that this works is we can take algae, we can preferentially pick a species of algae that has a higher fat content. We can grow it artificially, and we can even grow it close to something like a coal-fired power plant in these kind of warm pools, right? That's all artificial. We can just fill them with lots and lots and lots of algae. We're adding oxygen to the water. And so they'll pile up in this big sludge, and we can take those and compress them, dry them, put them into these little kind of chips. And at that point, you can either use alcohol or sonic waves or other things to break the cell walls and essentially create hydrocarbons. And basically what we're doing there is, in the geologic world, oil is formed by fatty acids getting buried and undergoing these chemical changes. In this case, we're just growing the fatty acids and doing all of the geology work ourselves, right? So when you have renewable hydrogen, or what we call drop-in fuel, you're creating something that is basically chemically the same thing as gasoline, right? So again, its uses can actually replace gasoline. And when we look at kind of who's doing this work and where we see this happening, surprise, right? ExxonMobil and these kind of big multinational oil companies, they're the ones doing this work because that's where most of the petroleum engineers work, right? So this is not, someone trying to do some crazy experiment in their garage. This is real, right? Although, when we look at the kind of percentage of, what we consider carbon neutral energy sources, biofuels can be important, but they don't make up a huge portion of the offset. So the goal of creating electricity, right? We're going back to electricity, is spin the magnet, right? And generally, one of the things that we've kind of been through as we're going through this discussion is many ways that we use to generate electricity are just fancy ways to spin the magnet, right? Whether we're burning coal to boil water, whether we're burning natural gas to boil the water, or we're using the decay of uranium to boil the water. lots of different applications in that sense. But at the end of the day, all of those are boiling water and spinning the magnet. In the case of geothermal, we've got the water already boiling, right? Whether that work is done, so you don't need an energy source to boil the water. You have to excuse my artistic application here. Again, this isn't actually what a geothermal power plant looks like, but it's got the pieces and parts that we're concerned with. So when we have geothermal power, we have to find a place where there's a geologic reservoir or a source of heat within the earth. We call that the geothermal gradient. And there's plenty of places on Earth where there's significant hot water. Oftentimes that can be as hot as 300 degrees Fahrenheit. But you might be saying, wait, water boils at 212. And that's true, but not under pressure, right? That's actually how your Instant Pot works, or your pressure cooker. So under pressure, the water can heat to a higher temperature because it's confined. It won't actually go to steam. It won't boil. It'll just get hotter and hotter and hotter under pressure. So we take advantage of that here. So we find a place where the water is hot enough, and we essentially drill down and put in a well, like a typical water well. We bring that water to the surface. One of the things that we have to be really careful to do in this case is we have to make sure that it stays pressurized. We can do that with our extraction methods. So this super hot water that's above the boiling point of water is brought to the surface, and then inside of a geothermal power plant, it's essentially depressurized in a confined area. We have a low pressure area where that water then essentially flashes to steam, something you might think of as like a geyser, right? It's actually how a geyser works in some ways. And when that water flashes to steam, and like I said, that happens automatically because the temperature is above boiling, we then have steam, right? Which is what we spent all this energy getting. And we can use that steam to spin a turbine, as we do, and that spins a magnet inside of our generator, and that produces an electrical current. We then take that wastewater and re-inject it. And so this is great, right? This is a great way for us to produce energy. The limitation is you have to have a location with significant groundwater resource, and you have to have enough heat in that water to make this happen, right? So if your water temperature is coming out of the ground at 170 degrees Fahrenheit, that's hot. You could cook with it, kind of. It would cook the heck out of your hand. A hot tub is usually what, like 103, 104? So it would not be pleasant, but it won't boil. It's just really, really hot at that point. That's a challenge, right? And so we can overcome it a couple of different ways. In Boise, you're probably familiar with the concept of geothermal, but we use what's called low temperature or passive geothermal, where we take this water and we actually just use it to heat things, right? We take the heat out of it and use it for heating buildings and such. So it's not necessarily that we generate power. Although locally, there's the Raft River complex, which is down kind of near Pocatello-ish in that part of the state. There's a geothermal power plant there that actually runs this way. There's one out in Vail, Oregon, not too far across the Oregon border from where we are. And I think the biggest one in the United States is called the Geysers in Northern California. Generates a significant amount of energy, actually. The water's hot enough, and it does actually produce a decent amount of power. Globally, the place that's probably the most famous for this is actually in Iceland. And kind of depending on how much you know about geology, Iceland is actually a place where the mid-Atlantic ridge, which is really incredibly volcanically active, actually sticks up out of the ocean. That's Iceland. So there's no shortage of hot water there, right? There's plenty of geothermal activity. And you'll oftentimes see photos, anytime there's the discussion of geothermal energy, you see this kind of one specific geothermal power plant. But again, one of the hallmarks of a geothermal power plant is a bunch of pipes running all over the place, right? Because you're getting this hot water, you're recondensing it and injecting it. And actually, one of the things that's usually the most visually striking is actually the one of the things that's most striking when you look at a geothermal power plant is actually the condensing units, which are cooling the water through convective cooling and actually use that to recondense it and inject it back into the ground. So again, this water is potentially water that later gets heated up and used again. So this is a pretty cool application, but it really has limits in the scalability because there aren't very many places that you can do it, right? It's kind of inherently limited to places that have hot enough water to achieve our goal of flashing to steam.